So, hello everyone, my name is Navneet Kumar. I am a student of Sri Venkateshwara College of Engineering, and today's video is on the topic TCP IP protocol suite. So, this video is made by referring the journal of Ashima Tyagi on the topic TCP IP protocol suite. So, let's dive into it. So, TCP and IP basically stands for Transmission Control Protocol, and IP is Internet Protocol. So, it is widely used for communication over the internet, right? So basically the suite of TCP/IP enables communication between two devices or entities on a network, right? But the entities must agree on a protocol, which is a set of rules. So what is protocol? Protocol is a set of rules that define how communication happens, right? And a protocol suite is a collection of protocols used across all layers, right? Our TCP/IP has 5 different layers. Okay, so we'll see how it is done and how the control of data flow is done between them. So the first layer of TCP/IP is application layer, then we have transport layer, then we have network layer, then we have data link layer, and last but not least we have physical layer. So let's start with the physical layer. Physical layer is responsible for the representation of data into bits, synchronization of data and the data rate, and it also defines the transmission of medium and the transmission modes, right? And some of the protocols defined in the physical layer are Ethernet, Bluetooth, Universal Serial Bus. Yes, my friends, this is USB, which we all use, right? So what are those basically? So Ethernet is a LAN technology. Okay, it is used to connect systems to LAN. LAN is a local area network, right? So with the help of protocols to control the passing of information and to avoid collision, we use Ethernet, right? And it has the speed when we are talking about, it has evolved from 10 megabits per second to gigabits per second. 10 gigabits per second, with faster speeds and better cables for data transmission and reducing collisions. Different Ethernet types uses various cables like twisted pair or fiber optics, or we have like coaxials, right? So basically they are suited for different distances, right? And when we're talking about Bluetooth, that is basically wireless, we can say. So a LAN technology that is it is created to connect different devices like mobile phones, tablets, then we have computers, laptops, cameras, telephones, so on. We have seen so many, right? So Bluetooth has two type of networks, right? One is piconet, which is a small network of up to 8 devices, and scatternet, which links multiple piconets together. So you can understand how many devices can connect in scatternet, right? When we're talking about USB, it is an interface for fast transmission of data by connecting various peripherals to computer, and these interfaces are available on personal computer and laptops to peripheral devices, mobiles, phones, cameras, hard drives, and so on, Then we are talking about the second layer of TCP/IP is it is data link layer. Data link layer breaks the stream of bits into frames, and then physical. It provides physical addressing. It is also responsible for flow control and error control by adding a trailer to the frames along with the header, right? So some of the protocols defined in the data link layer are noiseless channel protocols, noisy channel protocols, and RAP, which is random access protocols. Now when we are talking about these three, noiseless channels don't have errors, right? So no error control is needed. So when it is not needed, why do we use it? We use it for simplest protocols, which sends data one way from the sender to receiver without flow or error control. No flow or error control, so no need to handle it. So stop and wait protocol uses acknowledgement to control the flow, with the sender waiting for a response before sending the next frame. The receiver sends acknowledgement to avoid getting too many frames at once, right? When we are talking about noisy channel protocols, it can cause us error control and flow control errors. It can cause errors. So for that we need to use error control and flow control. So we go with Stop and wait ARQ, which sends one frame at a time and waits for an acknowledgement. If a frame is lost or corrupted, it resends the data. Go back and ARQ sends multiple frames at once, but resends all frames from the error point. So if an issue occurs, it means it will send multiple data, and wherever the error is occurring, from there it will send all the data again. But when we are talking about selective repeat ARQ, it only resends the specific frame that is lost or damaged, which saves our time and bandwidth. When we are talking about RAP, it is random access protocols. It don't have any dedicated channel, so stations may collide when sending the data at the same time, right? So for this we have Aloha, which sends the data and resends if no acknowledgement is received, which indicates a collision. Or we also have CSMA. CSMA checks if a channel is free before sending, but collision can still happen, right? So different methods handle busy channels in various way, right? We also have CSMA CD. CD is collision detection. So it detects collisions during the transmission and retries sending the data, obviously. And while CSMA CA has CA, basically it is collision avoidance. So it avoids collision by waiting before sending, useful, and it is useful for wireless networks. When we are talking about the third layer of TCP IP protocol, it is network layer. Network layer, it is needed when two segments are on different networks. It ensures data gets from source to destination, handling logical addressing and routing. Some of the protocols defined in the networking layer are ARP, RARP, IP. ARP is address resolution protocol, and RARP is reverse address resolution protocol. IP is again our internet protocol, and there are multiple more protocols in this layer like BootP, DHCP, ICMP, IPsec, etc. So the three, which is ARP, RARP, IP, we'll see in brief. So address resolution protocol, which is ARP, maps a logical address to a physical address. Okay, when a host or a router needs to send data, it knows the recipient's logical address but needs the physical address for delivery. So the sender broadcasts an ARP request to find the recipient's physical address, and the recipient recognizes its logical address and responds with a unicast reply providing its physical address. Understood? But when we are talking about reverse ARP, it helps us finding the logical, right? It helps us finding the logical address when only physical address is known. Here it was opposite, and here, I mean, in this ARP we knew the logical, we wanted to find physical. In RARP we know the logical, I mean we know the physical, and we have to find the logical, right? So RARP is useful for dyslexed machines, dyslexed machines, like what do we say, um, NIC cards, yeah, like that. So machines that lack IP information stored on disk, right, like hard disk, like that, yeah. So using NIC card to get the physical address. So basically an RARP request is broadcasted, and another machine replies with the IP address via unicast message. RARP is limited because it can't broadcast beyond network boundaries, requiring an RARP server. For each network, BootP and DHCP replaced RARP. Okay. Now we'll see what is IP. IP is Internet Protocol, which defines rules for routing and addressing packets across network, right? Giving each device a unique IP address. For IP, we had two versions, which was V4 and V6. IPv4 is a 32-bit and IPv6 is a 128-bit. So basically it is a connectionless protocol that provides a no flow or error control and supports a total of 232 unique addresses, whereas IPv6 supports 2 to the power 128 unique addresses, right? So our IPv6 has better security and an improved header format, right? Now when we are talking about fourth layer of TCP/IP, it is transport layer. It does process to process delivery of a datagram. The responsibilities of the transport layer are segmentation and reassembly, connection control, flow control, and error control. So there are various protocols on this layer, some of which are described below, such as UDP, TCP, SSL. Right, UDP is user datagram protocol, TCP is transmission control protocol, and SSL is basically secure socket layer protocol. So these are basically, UDP is a connectionless and unreliable protocol that offers no flow, error, or congestion control, right? But why we are using it? But we are using it because unlike IP, UDP delivers data process to process, making it useful for simple short transmission where reliability isn't a concern. UDP is efficient for protocols like TFTP that handles their own flow and error control, and is also suitable for multicasting. Okay, some of the common protocol using UDP include TFTP, RPC, SNMP, and NTP. When we are talking about TCP, which is transmission control protocol, it is a connection oriented reliable protocol that provides flow control, error control, congestion control. So it establishes a connection using the three-way handshake, right? SYN and acknowledgement. Yeah. So it ensures data transfer in both direction, full duplex. It is full duplex, and closes the connection using a similar handshake. TCP uses a sliding window mechanism for efficient flow control and manages error through checksums, acknowledgements, and the timeouts. So TCP also handles congestion by adjusting the window size based on network condition. When we are talking about SSL protocol, it provides data, it protects data sent over the internet by encrypting, compressing, and signing it. So setups, key securities, settings for secure communication, and changes to new keys when needed during communication. So reports any error or issue during communication also. Last but not the least, yeah, so it is application layer. It is the main function is to provide services to the user like file transfer, access, and management, mail services, directory services, and so on. So some of the protocols which can be defined in application layer are telnet, SSH, FTP. Telnet we all know, SSH is secure cell, FTP is file transfer protocol. So there are many more protocols in this layer like POP3, IPAM, AP4, and SMTP, simple mail transfer protocol. So yeah, so what is telnet? How telnet works basically is it allows connecting to remote devices, making your local terminal act like you're using a remote system, just like how we use any desk, right? So it enables you to interact with devices located far away, commonly used to manage and control remote devices by connecting to their IP addresses and or host name. Whereas a secure cell is a secure way to control or manage remote servers, replacing telnet. It encrypts all communication to keep them safe and secure, uses the same key to lock and unlock data for both sender and receiver, and uses two different keys, one to lock, which is public key, and one to unlock, which is private key for the data. FTP is basically used to transfer files between two computers using TCP, transmission control protocol. So two connections are made, that is one for sending data using port 20 and one for control information, which is using port 21. So the control connection stays open for the whole session, while the data connections open only for file transfers and closes after. So in conclusion, I would like to say the transmission control protocol model is used wisely in the field of communication. It works along with IP, which is Internet Protocol. So it is a hierarchical, meaning that every protocol of lower layer supports the protocol on the above higher layers. And in this article, we have covered the working of protocols that function over all the 5 layers of TCP/IP, from bottom layer called physical layer to the top layer called application layer. These are the references, you can go through it. Ashima Tyagi, TCP/IP protocol suit is her journal, right? It is an international journal, and these are the link. I'll put it in the description also, right? So with this, I would like to thank you guys. Thanks for watching my video. If you like, Please like the video, and if you have any doubt, comment on the comment section. I'll go through it and help you clarify it. Thank you.